Hi everybody, thank you for attending our webinar this afternoon. TRIOS is a name synonymous with quality digital scanners, but you may not be aware of just how much you can do with an intraoral scanner now. It's really the starting point for a whole world of digital dentistry, including smile design, treatment simulation, and you can plug into a CAD ecosystem that includes crown and bridge, implants, splints and orthodontic applications. I'm Bruce, by the way, equipment manager with Henry Schein. And this afternoon, we've got training and application specialist, Richard Schumacher from 3Shape, and our own senior CAD/CAM technician, Dustin Jacobson. Richard and Dustin are going to give you a taste of what you can do with a TRIOS, focusing on chairside design using Design Studio, and milling a crown with the VHF Z4 mill, which is a trusted connection between the two manufacturers, VHF and 3Shape. The presentation will take about 40 minutes all up, and there'll be time to ask questions afterwards. So I'll hand you over to Richard, who's going to begin with a short video and then a live demonstration.
Okay, so this is an introduction. I have a really small amount of time, so I may talk really quickly. I do slow down at some stage. But I have a lot of material that I want to cover because digital, there's so many facets to it. It's actually a really great platform. I come from an analog world. I was a technician for a very, very long time, 25 years, non-parole. And I've done some other things. You don't have to read this. I'll send you a postcard. This is what I do on the weekends, just to step away from that sort of corporate image. Obviously, I'm a body double. Okay, so a little bit more seriously, digital dentistry. Every second there's a digital crown made through 3Shape software. So you can imagine there's a lot of people doing this type of thing. Also, the growth of the TRIOS scanner from our own data, we had a 90% growth in the 2017 to 2018. I don't know what it was in 2019, but that's a really strong indication that people, well, clinicians are really jumping on board to digital dentistry. Now, coming from a laboratory background, labs have been digitized for 15 to 20 years. So this is the final step in what we call a full digital workflow, which means scan or data acquisition and then et cetera, et cetera. Okay, Bruce just touched on smile design. This is part of the TRIOS 3 and TRIOS 4 package. It's free when we released it. And what it is essentially a smile design proposal that you can actually show your patient and have an open dialogue with them about a proposal, whether it's bleaching, veneers, full coverage crowns, et cetera, et cetera. But the important thing is it's about education and actually discussing these types of potentials with a patient. This is like pre-treatment. Treatment simulator is the same. This is geared towards orthodontic treatment, obviously. And the software, we have like an external server that actually moves the teeth into an idealized tooth position. All you need to do as a practitioner is take the intraoral scan and press calculate, and then it comes back with a proposal. Again, it's just about a discussion. It doesn't produce anything other than images, and then you would use those images to discuss with your patient the potential of some form of orthodontic treatment. You would need to triage that case, whether it's going to be clear aligners or banding of teeth. Obviously, you need to, respect the biological principles of orthodontics, but you would do that at a later stage once you've got patient acceptance. This part of the software, this is called TRIOS Patient Monitoring. And you're going like, wow, what's all the fuss about? You've got green teeth. This is a color map. The color map shows the changes in either the tooth surface, the tooth position. Also, we can look at gingival changes, so gingival recession, et cetera, bruxism, tooth erosion, tooth chipping, orthodontic movement. You can use it to monitor an orthodontic case. It's really, really powerful software. You build a profile of your patient over time, and you can start to intervene and actually provide some form of treatment before things get really, really bad. This case, obviously, there's something going on with the banding and the patient's pivoting off those sevens. So maybe you would like to say to the patient, maybe you need an occlusal splint. Okay, some other fantastic stuff, and it's a first for 3Shape also. We're all used to static or habit bites. So it's in a static position. We're also able to capture the patient's own specific movements. And that includes a parafunction, obviously. If you've got I know I've got a sort of lazy articular disc that kind of clicks, doesn't cause me any pain, but it changes the movements within my own jaw. And I've seen that by scanning myself, that you can actually see that little jump when it isn't functioning properly. So fascinating, really powerful information that we can capture through digital that we could never get before. Previously, from this side of things, patient-specific motion, we would actually try and capture data with a pantograph, for example, where we were trying to trace the contour of the glenoid fossa. Really complicated thing to do, but that's where it comes from. It's simply done with a scan in about 2 seconds. Okay, so I'm going to just talk a little bit about our platform. Now, what we call an ecosystem is what can you do with a scanner? And you can send out to multiple or create multiple types of appliances, sleep appliances, Adventist, et cetera, Somdomed or whatever. You can send out to them just digital scans using a George gauge, opening the bite and protruding the jaw forward, or however you take a particular bite. Clear aligners, we've got implant studio, implant software for creating surgical guides, et cetera, and obviously crown and bridge. And there's a real movement, again, towards digital dentures, so we can also do that type of treatment modality. These are some of the treatment workflows that you can get just by scanning and just by sending. So if that's the simplest thing you want to, if that's all you want to do, and you just want to digitize your practice, you have all these types of restorations at your fingertips through the laboratories that you work with. Really, really great stuff. So it just improves your capacity to provide effective treatment to your patients. Okay, so TRIOS Design Studio, what is it? It's a software package that is an add-on to TRIOS, and it enables you to do same-day dentistry. And what that means is you take a scan, your data acquisition, within the software that I will show you shortly, is you can design a crown, and then that you create what we call an STL file, and then that goes to a mill. And that's where Dustin will take over from within the discussion today and show you the aspects of the milling, et cetera, et cetera. So a patient could come in the morning, you do a scan, you do the design, you mill the crown, and depending on what material you choose, you may just need to polish a hybrid material, or maybe you would glaze some form of glass ceramic. So it really depends on the clinical situation, the type of restoration, and what you're trying to achieve. But Dustin will cover some materials later on. So just to reinforce what I said, 3 steps, 3-step plan, okay? Scan the mouth, super easy. When you become proficient at scanning, you can do an upper and lower scan, full arch, with a static bite and also patient-specific motion in under 5 minutes. That does vary between patients, obviously, because of access, et cetera, but as clinicians, you would always know that anyway. The design steps I'm going to show you, it's really quick. I wouldn't even consider it any time investment at all, maybe 5 or 10 minutes, okay? You could have someone, an auxiliary staff member, doing the design for you on a workstation, for example, and you can start to see another patient. So that business workflow, that business model can really change how you do things within the practice. You could even train an auxiliary staff member how to take a scan. It's a digital camera, essentially. We're using light. We're not doing anything else but capturing images. And the production steps, you would obviously, chair side, you would have this set up, and then you would just choose your material and then cut it out. Okay, so you can see already on the right-hand side that the software does the crown design automatically. You do have some tools that you can change those shapes and contours, and we have a series of libraries which we'll see in a moment. You choose what material you're going to use, okay? That's pretty straightforward, and Dustin can actually advise you on what particular materials suit certain situations at a time that's convenient for you and Dustin. So I would reach out to Dustin for that. Okay, so demo time. So just bear with me. I'm going to reshare my screen. I'm going to choose a new screen, obviously. And I'm just going to close this. So just bear with me. Oops. Okay, so I can assume that no one can see anything, but that's okay. Okay. Okay, I'm sharing it now. Can someone, one of the co-hosts, just sing out when they can see? You'll see it die on the screen. Okay, perfect. And thanks everyone for being patient with waiting for me. I have a whole lot of different windows open. Now, okay, so I've captured the scan. I've taken the digital scan. I've filled out the lab form. That's easy. Everyone knows how to do that. You fill your name in and you choose a lab. Okay, and an issue date. This step, we're actually defining the margin. Okay, now I've changed it into monochrome, so I can work on a color model because the scanner actually captures color and it takes shades too. Okay, that's another thing. But I think we're one of the few scanners that actually takes a very accurate digital shade taking or shade matching procedure. Now, when we're defining margins, sometimes it's preferable to work in a monochromatic step so that we can look at shapes and contrasts and so forth. There's also a feature where you can trim the adjacent teeth away so that you can actually look closely to the margin. Now, when I had a laboratory, I had a microscope and that went up to 40 magnification. I thought that was really powerful in those days. But look at this. So what's the ratio of this image to what we could see in a stereo microscope? This is much better, okay? We can change the preparation, the margins, obviously, we can adjust them, okay? I'm not going to be too pedantic today with making a perfect margin. I know you can all do this, you do it all the time, you're cutting preps, you know what margins look like. The software is really helpful. That was predetermined, that marginal step, and you just adjust it. The next step, path of insertion, okay? The computer does it for you, it's automatic. You can analyze and have a little look at your preparation. There's a little color map, well, there's a little, okay, 0.03. This isn't anything that's going to concern me in terms of an undercut, but you can see the power of digital is it gives you a measurement and you can make a decision on whether you wanted to change the path of insertion, but just trust the software. It does a great job, okay? So leave it alone, don't do anything else. Okay, margin, path of insertion. The cement space and the cement gap is pre-calculated. And I'll also show you in a moment once we actually create a crown. I'll do a cross section and there's actually a drill compensation aspect to the software, which is really, really handy. Something else you don't have to think about, the software does it for you. Okay, so the software is already pre-designed a crown, and if I wanted to, I can change its shape. I can do anything. It's like, this is like chewing gum. I can modulate the shape. I can rotate the image, anything I want. I could also mirror a crown from the other side. So I've just told the software I want the software to copy the tooth, the 1/6 over to the 2/6 site, and it mirrors it, it reverses it automatically. So that's exactly the same tooth as that they have on the other side. If I wanted to choose something from a library, I can also do that. So maybe we just want a little bit more Fisher depth or whatever. So it's calculating here and it will change that momentarily. It may be a touch slow because I'm actually on the internet broadcasting. So that's actually really, really quick, provided you have a really strong, stable connection. Okay, so I was talking about a cross section. So let's create a cross section here. I can just draw a black line, and then on the bottom right-hand side, you can see a couple of things. You can see the outside contour of the crown. This black line is the minimum thickness. So I pre-chose a dilithium silicate material for this restoration. It has a minimum thickness, I think, about 0.8. I can't remember by chance. 0.9, okay? But I think I've captured where the cement space is. So I think it's 0.8, 0.9. That helps you with the crown contour because you don't want to breach that, that minimum thickness because it will affect the integrity of that particular crown. If we look closer, you can see that the preparation is quite sharp, and then the software predetermines what we call the drill compensation. It mills out extra room because of those sharp edges. Sometimes those sharp edges are too small for the reduction or the mill or the burr that we're using. So it's something to think about in terms of your preparation or how you finish your crown. So let's have a look at the actual shape. I'm going to turn it into monochrome. And what I'm talking about are these little sharp edges here. That's not great for all ceramic restorations, but I'm not here to teach you about how to do tooth preparations. I'm demonstrating the software, but you can see the power of it by looking at cross sections and things like that if you chose to. You don't have to do that if you just want to create a quick crown. You just plot the margin, analyze the path of insertion, choose a crown form from the library or mirroring an extra tooth, make some adjustments, and then you're away. Then you can actually start to mill the crown. Now, let me just, I'll bring back the color. If you wanted to change things, so say you're doing a canine and you wanted to change the canine guidance, for example, there is an articulator function in here, and you can see just a little bit lower here. If you look at the incisal table, I can adjust it. So you can hopefully, maybe I'll make it bigger. So I can adjust it. So I can modify the disclusion if I was doing a canine. But again, if you don't want to drill deeply, you don't have to. It can be very much what we call next, where we just go to the next step. So the software is designed to be as simple as it can be, but for those who want to drill deeply, you can. Okay, so I'm going to, I'm just going to remove this and get rid of the articulator. So I bring back that crown. You can see here that little pink section, that's the minimum thickness. And I don't think it changes the shape or the contour too much. So I would be quite happy with it. If I actually wanted to make small changes, we have a wax tool. What I do here, so I just make it stronger. So we can add on, okay? And we can remove, okay? That's just to demonstrate how fine the tools you can use. This is like kind of like a belly button. So we've got an innie and an outie. And this is the smooth tool. The standard joke that I use most of the time is that they named this after me, the smooth tool, so you can smooth things down. It's a little bit like a brush foam. So hopefully, I can't hear anyone laugh, which is unfortunate. Okay, so once we're happy with the crown, we can actually adjust the contact points specifically, whether you want them stronger or lighter. It just depends on your clinical style or potentially how long the crown, the case has been temporized. Sometimes the teeth shift in, maybe you want soft contacts. That's your decision. Okay, last step, and then it's over to Dustin. Once we've created the crown shape, the software automatically nests it into a block, okay, a milling block of your choice, or material choice. And you can see here that that's the shape that we created. And then it would go to the mill. So that STL file, or the data that I've created, goes to the mill, and then it gets cut out of the block. So Dustin, now it's your part of the webinar. So we'll stop sharing and you can jump on.
Happy days, thanks Rich. All right, sorry, let me just get my sharing up. There we go.
And I'll just turn my mic.
There we go. Can one of the other panelists just advise that you can see my screen?
Oh yeah, sorry, yeah, it's up.
Okay, all good. All right, what I'm going to do for you guys today, we made a video in our showroom. Obviously with COVID, we can't do a live demo in the showroom, but this is just basically showing the connection between TRIOS and the Z4 milling machine. Today we're going to be talking about TRIOS Design Studio and a trusted connection with the VHF Z4. So once the crown has been designed, we come into our now nesting stage, which is the cam section. The software will automatically place the crown inside the block based on the optimal position. However, if you do want to change the position, you can simply click on the crown, and by using these handles, you can rotate the crown to a better suited position. What you can also do is change your sprue location simply by clicking on the sprue and moving the sprue around. However, if you do want to just set it back to the original position, you can go auto nest. So there, our crown's nicely placed in the block. We now need to select milling strategies. So if we come up over here, you can see we've got an option for 3 different milling strategies: standard, high definition, and fast. High definition is a lot higher definition cut, but does mill slightly longer as compared to a standard definition. A fast milling strategy will give us less definition. Once you are happy with your milling strategy, you simply click on produce and the job will be sent to the mill. Once we're done, we now need to get the mill ready for milling. First thing we need to do is select the correct tooling. So we can see over here we've got a couple of different tooling options. First block of the white is for grinding, the green is for plastics, the blue is for zirconia, the yellow is for composites, and the red is for metal. So because we will be doing grinding, what we're going to do is simply take our milling block, milling tools, and place it in the machine like that. One thing to mention, this machine, you can see the water tank over here. You only need distilled water. There's no need for additional solutions or additives. Once that's done, simply close the drawer, take your material, lock the material into place. Once that's done, simply click play. The mill will start. There we go. So once milling has been completed, we remove the block from the mill, delete it off the mill, and then we can continue with the fabrication of the crown. Some other interesting facts on the machine. The machine has a built-in compressor. The compressor is used just to clamp the mandrel in to hold the material. It's also got an integrated CAM and CNC computer, so there's no additional need for additional computers to run your mill. It's also got an integrated webcam, which helps with servicing and support, so we could always connect remotely and see what is going on with the machine. The other thing, it runs on an electric spindle, 100,000 RPM spindle, so it's a very robust and strong spindle. Cool. All right. The other thing I just briefly want to go over, which Richard started mentioning, was material selection. What we see over here is a tooth nested in a Vita multi-layered block. And you can see the software will actually show you the different layering. So you can also move it up and down depending on the shading you want on the crown. But if you decided that you'd rather do this in ceramic, it's quite simple to change. But obviously with materials, we've got different values and minimum thicknesses. So a redesign is required. So I'm just going to select Emax, Z4. And then we're going to go into the design. And what the software automatically does is adjusts the cement space and minimum thickness values for the entire crown. So you can see it's busy running through design. At this point, if you wanted to do any additional modifications, you could. But we're just waiting for it to finish, and then we will go into the nesting side of it. Okay, design's been validated, so now we can move into the CAM section. So we can see what it's done here. It's told us that the I12 in Emacs, this restoration would fit. However, if you only had a C14, you can add it in there. The Z4 is able to take up to a B40 block. So you are able to do 3 to 4 units anterior bridges on it. Bridge milling time, the last bridge I milled out was roughly 35 minutes for a 3-unit bridge. Just to jump back into the materials, as it stands, 3Shape and VHF work together to collaborate and verify materials. So the current materials available on a trusted connection is Emacs, Impress, Serosmart, Saltradura, and then the Vita range as well. Following that, that's basically that. I just want to show one last video on the VHF Z4, and then I think it's Q&A thereafter. All right, well, that's it basically from my side. Rich, I think, is there anything you want to add?
No, I think it was good to actually see the mill too. So that, I really liked that video, creating perfection. I think that was written in the sky when I was born. I'm just joking. No, there's nothing for me to add. I think I covered a lot earlier, and hopefully it wasn't too fast and quick. But if anyone has any questions, they can actually post it in the chat component at the bottom of the screen, and then we can sort of answer some of those things. Is there anything more that you'd like to talk about, Dustin?
No, that's it for now. Eh?
I like the magic trick in the video where it was just edited so that the milling blocks were changing like 1, 2, 3, 4. That was pretty nice. But in terms of milling, it's easy. Essentially, all the stuff is done in the design. The human component is putting the block into the mill.
That's it.
And pressing play. And of course, you need to do the tooth preparation as a clinician. But that's what these guys are trained for. So it makes things really quick and easy. As I said, I came from an analog world. We used to hand wax those crowns, Justin. You're a technician also too, weren't you?
No, not officially. Oh, okay. Yeah.
We used to wax them. So we used to have to wax all those marginal ridges and fissures and everything. So you could imagine the time invested in just to create the tooth shape. But digital has changed everything for good. There is a question here. I was just wondering whether this integrates with any smile design software or software for full mouth rehabilitation and opening the OVD. So, okay, so I'll start from the last part. Opening the OVD, so when you saw that articulator that I demonstrated, you can increase or decrease that in size or pin. So yes, you can open the OVD. Smile design software, TRIOS has smile design. Now, when we talk about smile design, if you recall, I was saying that it's a piece of software that works to have an open discussion with a patient. So we work on a 2-dimensional photograph. But having said that, if you took a digital surface scan along with that 2-dimensional photo and send it to a lab with the lab software, we can merge the 2-dimensional photo with a 3-dimensional scan, and then in a what we call real view engine, actual wax up. That wax up would replicate the tooth form and tooth shape, center line, incisor length, et cetera, done in the design software, Smile Design software. And then that can be replicated on a model. They would 3D print that model, and then the practitioner would use that model to show the patient. Some patients are kinesthetic, they want to touch things. But the other thing is, if you use silicon keys, you can use that model of the diagnostic virtual setup, but in a 3D printed format, for temporization of the case when you come to the preparation step. So what we're doing is we're working in reverse to some degree. So we get the end result from Smile Design. We create the three-dimensional tooth forms in the laboratory software, and then we temporize the patient. And the tooth forms and shapes are the ones that were discussed in the Smile Design step. And you've got consistency. So you've got the temporaries will look exactly like the definitive restorations, which is really important. From when I was at the bench as a technician, it was really hard sometimes to copy exactly because everything was done by hand. But with digital, it's just a click of the button and it replicates things. So it's powerful in that sense. Yeah, so it does integrate with Smile Design and software, and we can produce 3D models. And of course, you can do full mouth rehabilitation. TRIOS Design Studio, you'd need to look at the size of the bridge or the span of the bridge. And of course, you can do as many singles as you like. But if it was a full mouth rehab, you could do it. I wouldn't do it as your first case. I always like to, I would always like to work with a laboratory. There are a lot of other, things that you would need to address. And if you're talking about changing OVD, it's about bites and replication of bites and all these types of things. With the use of Smile Design, the first thing that's important is you can get that center line correct, incisor length and tooth widths and forms. Smile Design is also based on DSD, so digital Smile Design, and using the golden proportions to actually measure the mesiodistal widths of different specific teeth. It is really sophisticated software, and it's really made simple for the practitioner because essentially you want to have that dialogue with the patient. You can do it chairside or you can do it after. It really depends, but so that's it. Yeah, the design. So to confirm this would be in the laboratory on something like Exocad or don't mention that name. If you're doing a Smile Design proposal and you're taking a digital scan, you have to work within our platform. So if you're doing Smile Design with a Smile Design from TRIOS, it's not going to go into Exocad, okay? So you need to work in the same format. It's kind of saying, I have a Mercedes, but I'm going to put on Mazda wheels, okay? So you would work with the lab with the 3Shape software. Communicate. So what's Communicate? Communicate's a cloud-based server that we use to send the data. So you would capture your surface scan, and then you would choose a laboratory, and then it goes into the cloud, and then from the cloud back down to the lab. Now, Communicate is helpful because you can also send a patient, it's called My 3Shape. It's an application that you get on your iPhone, and Communicate's also on iPhone. So you can communicate with your laboratory from anywhere you are if you've got your phone. And the patient, you could also send them their own scans or send them their Smile Design proposal. They may want to take the Smile proposal home and talk about it with their partner and say, look, wouldn't it be great? I really want to change my teeth. And, I've never been happy with my smile and the color's wrong, et cetera, et cetera. This is what I could look like. What do you think? And then they get the buy-in from the partner. Then you've got patient acceptance. So there's lots of other things involved with digital that have that human component to it, and the ease in which we can do that, which is the fantastic thing about digital dentistry, is communication, patient education, then the patient really knowing what they're going to get before they commit. Do you want to add anything, Dustin? Or we need more questions?
On that side there.
The other thing, so this is another thing that I don't think we mentioned, Dustin. This workflow, so we're talking about a digital scanner, you know, a TRIOS scanner and a mill. There are other chair-side systems out there, but they're closed system and they're not scalable. What that means is you buy everything at once. So you could do that with TRIOS and a Z4 if you chose to, but it's also scalable. So you may want to start with a scanner and then in a month or two, look at the mill. I mean, I know Dustin's going, no, don't tell them that. But no, I think it's important. I think it's important to know so that you can make an informed decision and scale your practice to what you're ready for. Okay, and that's the beautiful thing about TRIOS. It's an open system, and also the Z4. It's an open system, so it can accept other scans from other places also. So if you're not familiar with digital, if you just remember STL file, that's the industry standard in terms of file data that gets sort of sent around for either reductive milling. So this is what we're talking about today, and additive 3D printing. So you could actually, if you had a printer and you had the right material, you could actually print a temporary crown, for example. So if you had a case where maybe you need to address the gingiva and wait until that settled down, you may want to create some really nice temporaries with closed margins, no overhangs, the correct emergence profile, et cetera, as opposed to a temporary that you make with an alginate. You know, that's messy and untidy, but again, it depends on the clinical case. So if you're doing a really large full mouth reconstruction and you were changing the OVD, I wouldn't go to definitive restorations. I would temporize the patient and watch and see how that patient accepts that opening of the OVD and look at the wear facets that are created, and are there any other issues with the TMJ, et cetera. So for that type of thing, you want really, really good, well-made temporaries that you could do with a 3D printer.
We talk about scalability. We did an installation up in Fiji where the TRIOS was installed in January and the Z4 went down in September.
Fantastic.
They just wanted to stage it, so that worked out very well for them.
Yeah, I think it's a good idea. And I mean, you would definitely talk to Dustin about those sorts of options and how you go about it. But that's not part of what I do. I just train people. So that's why you would speak to Dustin. He's an expert on all those different setups and so forth. Oh, there's another question. Is that a new one? I just refresh it.
It's a new one. Mentioned fabricating full dentures with the system. Can you talk us through the process?
Okay, so digital dentures. So with a digital denture, you'd be taking a scan of an edentulous mouth. It's a little bit harder than actually capturing a digital scan of hard surfaces or teeth, because teeth are stable, the shapes don't change. Now, keratinized tissue is reasonably stable, but it does move. There is a feature in TRIOS that's called AI, so it's artificial intelligence. So if we're scanning a dentate case, the software can recognize mucosa, cheeks and tongues and fingers and toes, okay? And it will remove them, okay? It will chop them away automatically. And when we take a digital scan of an edentulous mouth, we turn that function off because we're trying to capture soft tissue. Now, the Z4 won't, obviously it's not a 3D printer, so you wouldn't be able to print a 3D denture base. There are systems that would mill a denture base out, but the same procedures that you would follow in terms of the traditional methods of digital dentistry for dentures or full dentures, you would follow a same sort of path. In the laboratory software, you can actually choose denture teeth and position those teeth into the correct position for that particular patient. So in terms of what TRIOS does, it's the data acquisition for the edentulous arches, upper and lower, and then you would still need to work with a dental laboratory to produce the restoration or the full denture. Whether you do it reductively, milling it, or additively with a 3D printer is dependent on the lab that you work with. that it is, there is a massive market for dentures globally. I think we kind of forgotten about them when we had crown and bridge and implants. We think, oh, dentures are the thing of the past, but they're actually not. And that's why there's been a lot of time invested in moving towards that part of the market. Hopefully that's answered your question. It's probably a bit broad, but it is a possibility. But you'd still want to work with the laboratory because you need the laboratory software to do the tooth setup, okay?
And that lab software is 3Shape Dental System Premium.
Correct. Yeah, you'd work with a lab that's familiar with dentures. Not, you know, some labs specialize in crown, bridge, and implant prosthetics, for example. Then you've got orthodontic labs, specialized acrylic labs, et cetera, et cetera. But I'm sure most practitioners have a number of labs that they work with anyway. Oh, that's that same question. Okay. There is a digital face bow. I can't remember the name. I'll find out for Dustin, and if you're interested, just contact Dustin and he'll pass on the information. It's essentially you use a capture, like you would do it's got like a 3-dimensional scan with an iPad for example, and you can digitize that face bow and then send that off to the lab. So we you know, I think what's the last thing that what can you not do with digital scanner? It's hard to really know. But from when we used to pack dentures, for example, because some people go, oh, you don't have muco compression, and et cetera, et cetera. But I think we wanted to compress certain areas of an edentulous case to capture suction. That was related to when we waxed, packed, and flasked dentures. There was a certain amount of distortion in the acrylic. So they didn't always fit so well. When we're 3D milling or 3D printing, that denture base is an accurate representation of the digital scan that you've got. So you'll find that you're getting suction anyway. So again, it's all about accuracy, and that's where a digital scanner, actually there is statistics that they're better than a polyvinyl siloxane impression, especially for crown and bridge and marginal capture and integrity. Pretty scary stuff. So 6.9 microns is the accuracy of a TRIOS scanner. Just keep that in mind.
The other thing you can mention is maybe we didn't really touch on screw retained crowns.
Okay, so there's two. So with TRIOS Design Studio, you also have the opportunity to create a chairside screw retained crown. So instead of taking an impression, when we take an implant impression, we used to use what we call an impression coping or an impression analog that stays in the silicon. We use what we call a scan flag, a scan abutment, et cetera, and it looks exactly the same. And the scanner recognizes the external geometry of that scan flag or scan marker, which then tells the software the X, Y, and Z axes of the implant or the implant position. And then you can create a crown, much the same as I did before, but this time you'd have a titanium base in place, which is in the software. Depends on the implant system that you're using. You just import the file for that particular titanium base. You would mill the crown and then process it. Maybe it's full ceramic, maybe you want to glaze it, and then you would lute it externally outside the mouth, because there are certain non-rotational components to the titanium base. And then you can issue it. So you can do a same-day dentistry with implants. If you like, maybe I can share the screen, and I'll go back. I think I've got a case. Patients, screw retained crown. Okay, so the first step, this is the step that I was talking about, in regards to the scan flag, and you can see it looks like an impression coping. Okay, we tell the software which scan flag we're using, and we make sure that it's aligned accurately. And again, we can make sure that it's spot on. This one is. We go to the next step. There's a crown already kind of half designed here. You can see it calculating. It's probably just changing it a little bit. Yep. I'm not going to change the shape. I showed you that before. I might just, I can remove the model so that you can see. Okay, I need to do some modification here because I need to reconnect it to the margin. But we'll do that in a moment. I just drag it longer. Okay. And then I just press next, which is on the top left-hand side here, and it goes to the next step. Now, the next step is actually creating the emergence profile. So we can see that the tooth's shaded. And then this is the border or the finishing line of the abutment. If I go to the cross section, you can see the opposing dentition, which is illustrated by that black line. The grey line is the exterior geometry of the crown that we created. And obviously this is a titanium base. The green area looks like a little bucket. I can left click and hold and I can change those contours. Now this black line is the surface scan, and you can see that the healing abutment or healing cap, or whatever, whichever one you want to call it, was essentially a cylinder bang, which is pretty common. You may want to displace some of this tissue. I would if I was to respect my crown design and I didn't really concentrate on it too much. So it's not an ideal looking case, but I'm here just to demonstrate what the possibilities are. If I was happy with the shape of the emergence profile, I would then go to the next step. And here you can see the crown. If I remove, don't be horrified with the design. I'm not a technician today, I'm just a demonstrator. And you can see that we have the contour that we created, which we can go back and change, obviously. I'll remove the implant. There's the titanium base. We can change these profiles. So I can do a couple of things. I can add on, like I said before, and I think I did the belly button parity, the innie and the outie, and the smooth tool, which is officially named after me. I can document that, and I'm only joking. So you can actually smooth this off. Once you're happy with that contour, then you can go to the next step, press next, and we can see the design with the screw access channel already in it. Now, the beautiful thing about the VHF and our software is you're not relegated to using blocks with predetermined implant channels pre-drilled into it. You can, the software and the mill will do it itself. So you can use any normal block. You're not restricted to some of those other ones that are pre-drilled. If I remove the tie base, you can see the internal aspect here. So these are the anti-rotational components that stop the crown rotating on the tie base. We would now create, it creates an STL file. So you could 3D print this too if you wanted to, if it was a temporary. Or if it was a definitive restoration, you'd choose the material of choice. You could even print it out in resin and cast it and do it in solid gold if you really wanted to. This may be a heavy crown, but I think any of the glass dilithium silicate materials or lithium silicate materials also, there are differences. It's a clinical choice. But that's essentially the screw retained crown component. And hopefully that's answered some of the questions. Are there any more questions? Oh, no. Okay, so
I don't have any on my side. Have you got anything there, Rich?
Oh, no, so question-wise, I think that's it. I think we're coming close to the end. Is there anything that, that you want to add to wind up, Dustin?
Sorry, let me just get off video, yeah? There we go. No, thanks for all your help, Richard. Really appreciate it. Yours and Naomi's. If there's any other questions or any other follow-ups, please let us know, and myself or any one of the other sales team will be in touch. Any further questions, please reach out. We'll definitely answer any questions you have.
And thanks everyone for your time. I really appreciate you tuning in, and it's really great to work with Dustin. Obviously, it's a cross Tasman production here. So Dustin's in New Zealand and we're here in Sydney. I think it's working quite well, but it's great to work with Dustin again. I haven't been to New Zealand for a while, so I haven't seen you face to face, but for probably 12 months.
Yeah, it's been about a year.
Yeah.
No, but that's
Right.
it. Cool. Let's close it off. Thank you again, everyone. Yeah, we're pretty much done.
Great. Thank you, everyone. Have a nice afternoon.